Greetings, my name is Anthony, and on behalf of my co-authors, Stephen, Iman, Christian, Mohammed, and Ali, I will be presenting our journal first paper entitled How Do I Refactor This? An empirical study on refactoring trends and topics in Stack Overflow. This paper has been published in the Empirical Software Engineering journal. Let's first start with the definition of refactoring. Refactoring is the process of improving the internal quality of a software system by restructuring the code without changing or adding to its external behavior and functionality. As an essential part of the software maintenance process, the field of software refactoring is well studied, with the research community proposing techniques and building tools to support developers with detecting refactoring opportunities in their source code and also providing code recommendations. Most of the prior work in this area has been empirical studies on open source systems. However, little is known about the adoption of refactoring activities in practice. For instance, is refactoring just limited to fixing code smells? Analyzing the perception of developers is critical in order to understand better what developers consider to be problematic in their code and how they handle it. Prior work has tried to fill this gap by interviewing and surveying developers. However, these studies are limited in how much they can tell us about the general population of developers. As a research community, we need to know what gaps exist between refactoring as research and its adoption in practice. To do this, we need to extract common refactoring intents that align with real-world activities developers perform. To this extent, the aim of our study is to understand the real-world trends and challenges developers face in refactoring their systems. To gain this real-world insight, we examine discussions between developers on refactoring concepts and activities. To study developer discussions, we selected Stack Overflow. This is the largest question and answer forum on the internet with over 19 million questions and over 1 million users. This rich and diverse data set will provide us with insight into real-world challenges developers face when refactoring their code. Hence, we proposed the following 3 research questions. RQ1 examines the growth of refactoring discussions on Stack Overflow. Through this R-Cube, we gain insight into the popularity of Stack Overflow as a venue for developers to seek assistance with refactoring code. In other words, we measure the volume of refactoring related questions and answers. Additionally, this R-Cube also helps us understand the technology landscape with developers refactoring their code by examining the use of tags. RQ2 utilizes natural language techniques to identify the key terms and phrases developers utilize in crafting refactoring questions. Our analyst presents a real-world and granular view of the problematic or challenging software refactoring areas developers require assistance. Finally, RQ3 presents us with the opportunity to understand refactoring topics that are popular among developers and topics that are difficult to answer on Stack Overflow. Next, I will explain the methodology for our study. Our study utilizes SO-Torrent, an existing dataset of Stack Overflow questions and answers. The dataset is hosted on Google BigQuery. From the source dataset, we extracted questions that had the term refactor in their title or had a refactoring tag. We searched the title for the term refactor as title concisely describes the primary purpose of the question. For each question we extracted, we also extracted all answers associated with each question. In some instances, an answer can be an accepted answer. In addition to the title and body of the question, we also extracted metadata such as the date the post was created, the person who created the post, the score and view count of the question. To answer our research questions, we followed a mixed method approach where we performed a quantitative and qualitative analysis of the data. Seen here is an example of the structure of a post. It should be noted that only a question has a tag and title. A question can have one or more tags. The tags are predefined and the user must select it from a list. The score is calculated based on the number of up and down votes registered users assigned to a question or an answer. Each question can have only one accepted answer. It is the responsibility of the person asking the question to mark an answer as an accepted answer. As I previously mentioned, we followed a mixed methods approach to answer our research questions. For our quantitative analysis, we used custom scripts, statistical calculations, and SQL queries to analyze the data, while our qualitative analysis included a manual analysis of a statistically significant sample of posts. In this table, we summarize the data that we extracted. Our extraction process resulted in over 9,000 refactoring questions. Associated with these questions were around 20,000 answers. Approximately 7,000 questions were tagged with the Refactor tag. The dataset we used for this study is available for replication and extension purposes. Details on how to obtain the dataset is provided in our paper. Moving on, I will now present the answers to our research questions. RQ1 is about the volume and growth of refactoring posts on Stack Overflow. This RQ is composed of three sub-RQs. The first sub-RQ examines the growth of refactoring-based questions and answers on the site. The second sub-RQ examines if a selected set of Stack Overflow users is responsible for the majority of refactoring-related questions and answers. Finally, the third sub-RQ looks at the tags used by developers in creating refactoring questions and the growth of these tags throughout the years. In this sub-RQ, we measure the volume of questions that had the term refactor in either the title or tag and answers associated with these questions. Our examination shows that an overwhelming majority of refactoring questions receive an answer from the community. Furthermore, we also observe that while the number of questions and accepted answers have increased, the volume by which they increased has been falling. Finally, we also observe that the refactoring questions typically receive a response without much delay, a median duration of 0.27 hours. This sub-RQ looks at the involvement of the Stack Overflow community in refactoring discussions. We utilize the owner user ID field to identify the creator of a post. We observe that developers who ask questions tend to only ask questions, while developers who answer questions tend to only answer questions. This shows that there are two groups of users in the community: those that seek help and those that are knowledgeable in the field and look to assist others in the community. Tags are an essential part of Stack Overflow posts. They enable developers to categorize their questions and also help experts quickly access the questions that they specialize in. In this sub-RQ, we manually examine the tags developers utilize and group related tags into one of 7 categories. We observe that most tags are related to programming concepts such as arrays, recursion, etc. However, the tags that developers frequently utilize are related to programming languages such as Java, C#, and JavaScript. In total, we discovered around 3,000 unique tags associated with refactoring questions. In summary, RQ1 shows that Stack Overflow is a popular venue for developers to seek assistance with refactoring problems. and most questions receive an answer in a short period of time. We also observe a rise in questions around dynamically typed languages such as JavaScript. As a question and answer site, developers utilize natural language to communicate with each other. In this RQ, through a series of sub-RQs, we explore the language used by developers to discuss refactorings. The outcomes from this RQ are meant to support a more robust analysis of refactoring rationale by revealing how developers discuss refactorings and what terminology frequently correlates in refactoring-related discussions. In the first sub-RQ, we examine the frequent bigrams developers utilize in composing their refactoring-related questions. Bigrams correspond to a sequence of two adjacent words in a sentence. The top bigrams include the use of tools and IDEs such as Visual Studio, the phrase legacy code, highlighting one of the reasons developers refactor their systems, and terms related to the extraction and movement of code. In the second sub-RQ, we examine the occurrence of known refactoring terminology or self-affirmed refactoring terms. We observe a frequent mention of key internal quality attributes, such as the term inheritance. We also encounter terms such as cleanup and redesign when developers discuss refactorings. Non-functional terms include readability and performance. The final sub-RQ involves a topic modeling analysis to discover the topics around which developers seek assistance with refactoring. We utilized LDA, an unsupervised machine learning technique, to determine the refactoring topics. Furthermore, we determined the optimal number of topics using coherence, perplexity, and a manual examination. We also applied a series of pre-processing steps on the body of the post. This included expansion of word contractions, removal of URLs, code blocks, stop words, alphanumeric words, and punctuations. Our analysis yielded 5 topics. Code optimization, where developers look to simplify their code to improve readability and reusability. Tools and IDEs, where developers seek assistance with performing complex refactorings using automation and also performing bulk renaming tasks. Architecture and design patterns, where developers look for guidance with applying well-known design principles such as SOLID and DRY to their code. Unit testing, where developers seek assistance with evolving their test suite. And database, where developers seek assistance to better maintain their lengthy and complex queries and scripts. In summary, RQ2 highlights 5 topics developers seek assistance with when it comes to refactoring. 2 key concerns shared across these topics are the improvement of readability and reusability of the code in their system. Additionally, developers also encounter challenges with automatically synchronizing refactoring changes across multiple software engineering artifacts. Finally, we come to our last RQ, where we aim to understand what types of refactoring questions are challenging to answer. Additionally, we also look at the types of questions that the Stack Overflow community considers popular. Similar to prior studies, we measure popularity using a question's view count, favorite count, and score. Next, we measure a question's difficulty by examining questions with and without answers and the median time for an accepted answer. Our observations show that questions on tools and IDEs are the most popular type of refactoring related questions. However, at the same time, these questions are also difficult to answer. On the other hand, questions on code optimization are less challenging to answer. And finally, database-related questions are the least popular type of questions. Our findings show that Stack Overflow is a popular venue for developers to seek assistance for refactoring challenges that they encounter. The findings we present in our study can be utilized by multiple groups of individuals to improve code maintenance activities. For instance, we see our findings benefit the research community, tool and IDE vendors, and the developer community. When it comes to the research or academic community, our findings can help in revamping course curriculum. For example, teaching students about refactoring database artifacts and how to improve reusability for SQL queries. With the rise in popularity of JavaScript and Python, more research needs to be done around refactoring for dynamically typed languages. The research community has made considerable strides in program comprehension research, but developers still struggle with improving readability. Hence, the research community needs to better collaborate with IDE vendors to integrate their research into popular IDEs. Tool and IDE vendors should look at improving developer productivity by automatically synchronizing refactorings between project artifacts. For example, refactoring the source code should automatically refactor the test suite. Our findings show that developers also have challenges with performing renames. The vendor community should look at incorporating some of the renaming refactoring work from the research community, such as name appraisals and recommendations. The developer community should look at extending coding standards, especially around naming, to other project artifacts. Finally, developers should proactively utilize code quality tools, for example code smell detectors, during implementation, as these tools will help catch issues earlier on in the development lifecycle and reduce the burden associated with code reviews. In conclusion, using a mixed method approach, our study not only shows the importance Stack Overflow plays in helping developers with maintaining their systems, it also highlights common pain points developers face when refactoring real-world systems. In brief, we show the rise in the refactoring of systems built using dynamically typed languages, concerns developers have with code readability and reusability, the refactoring of non-source code artifacts, and the reliance on tools in automating refactoring operations. Finally, through a series of takeaways, we show how our findings can help organizations with maintaining their software systems. We encourage the community to read our complete paper, the preprint of which can be obtained by scanning the QR code on the screen. And with that, I have come to the end of my presentation. Thank you.